Hello dear professors, I'm Valeh Ismayilov, a senior year computer science student at UFAS, and today I would like to present you my internship work at Microsoft, where I worked under the supervision of Hassan Hassanov, the mobile team lead. Over the course of my internship, I was fully integrated into the development team, and this experience gave me an opportunity to contribute meaningfully to a real-world commercial iOS application. The focus of the project was the development of a feature-rich, real-time taxi application by using modern tools and best practices available in iOS development. This internship project was highly technical, centered on building a real-time taxi application in Swift for iOS-based devices. Initially, I was assigned simpler tasks like fixing small bugs or implementing basic UI features. However, as I became more familiar with the code base and with the project and gained the team's trust, I was given increasingly complex and critical tasks that had a real impact on the app's functionality. This slide summarizes our development setup. We coded in Swift 5 using Xcode 15, targeting iOS 13 Plus to support a wide range of devices. Key libraries included UIKit for user interface, Combine for reactive data binding, Google Maps SDK for display of the maps, Alamofire for network operations, Lottie for the animations, and Skeleton View for shimmer loading effects. The architecture followed the MVVM pattern, model view view model, supported by solid principles to keep the code scalable and maintainable. A dedicated service layout managed all API points and network logic. Tasks were tracked in Jira while developers could monitor task progress. Code changes were committed to GitLab with every branch and merge request reviewed by both the team and the client. I also frequently used a Postman to validate API requests and responses before implementation. My first assigned task was to integrate Shimmer Skeleton View into the address search screen. This loading animation displays gray placeholders as you can see in the video, while data is being fetched, improving user perception of speed. For example, when searching for an address or loading fare options, users see gray rectangles. This was implemented using Swift Package Manager, which greatly enhanced usability as users are getting immediate feedback knowing content is loading. The overlay matched the eventual content layout, improving the polished feel of the app. However, at this screen I encountered a problem where fast typing caused all the responses to overwrite new ones, hiding Shimmer View prematurely. To fix this issue, I introduced variable to track the most recent update user input and discard outdated response before displaying the results. Another important task was building the travel history screen. This allows users to view and manage past rides organized by month. To ensure performance, I implemented pagination, loading 10 items at a time. This avoided crashes and unexpected freezes, which improved smoothness during scrolling. When a user taps on the ride, detailed information is shown, whether the ride was completed or cancelled, pick-up and drop-off points, the driver's detailed information, and the map route. A major issue I encountered was related to the shared map controller, a singleton class used throughout the app to display the map. When I added a map to the history screen, the main screen's map disappeared. To fix this, I modified the shared map controller to support multiple map instances, so each screen can render its own view independently and switch between instances automatically. As you can see in the video, the driver's information is the same for all rides. That's because we were using the test endpoints and test driver account for all our orders. Next, I worked on custom address selection. This feature allows users to pick an exact location by tapping on the map rather than relying on the text search. Here I faced a similar issue as in address search screen, where old request results were overriding new ones, causing the confirm button to activate prematurely. To fix it, I implemented a custom debouncer which delays the request and ensures the button is only enabled when the user had finished selecting a point. Another critical issue was related to API inconsistencies. When searching by typing, the returned latitude and longitude coordinates were provided as 999, as the backend used an internal location ID which was decoded at the backend to get the actual coordinates. This made it impossible to switch from typed input to map-based selection. To solve this issue, I found another API endpoint that returned the actual latitude and longitude coordinates and used those values to enable accurate selection and editing on the map screen. The most challenging task I worked on was implementing the multiple orders feature. This allows users to book and manage several rides simultaneously from one account, an uncommon but highly valuable feature in taxi apps. I created a new screen listing all active orders and their statuses using unique order IDs. For example, a user can book 3 or 4 cars at once and see each ride's progress in real time. This feature benefits corporate clients, families, or anyone managing rides for multiple people. It's also a major competitive advantage since few local apps support this capability. While implementing this feature, I faced a major problem. When the user clicked New Order or Back button, the app wasn't resetting the previous state of the application, as the custom navigation was used in the app. To deal with this problem, I wrote a reset function in the main view controller, which was called as soon as one of these buttons was clicked. This helped me to fix this issue and correctly manage multiple orders at a time. This slide summarized the main results of my work. All features I developed, from shimmer loading and address refinement to travel history and multiple order management, were successfully implemented. This improvement significantly increased performance, user satisfaction, and app reliability. By addressing typical issues in location-based apps such as poor loading feedback or rigid order flows, I delivered a smoother and more flexible user experience. Now I'd like to briefly discuss the weaknesses of the current implementation and provide proposed future improvements. The app currently lacks WebSocket support, so updates are fetched every 5 seconds using polling. This causes visible lags in car movement and in-order state changes. Additionally, there is no offline support, which means users lose track of their rides in unstable network conditions. To solve these issues, I proposed implementing WebSocket communication for real-time updates and integrating local caching for offline access. Also, now app does not have a great error handling support for users. If something goes wrong, user won't be able to understand it at a time. To fix this issue in future, we will add more cases for each error to display it as an alert for the user. Further, I suggest using AI to offer smart route suggestions and predictive address completion, which could greatly enhance user impression of the app. Some new features could also be implemented, such as trip sharing. That could increase the security of the passenger during the ride, as they will be able to share their ride in live with the trusted person. In-app driver-passenger chat could also help people with disabilities, especially for those with hearing and speaking disabilities, to communicate with each other easier. Tipping feature could be very motivating for drivers to provide with better ride quality in future. In conclusion, my internship allowed me to deliver meaningful features to iOS production level taxi app and deepen my understanding of professional iOS development. The solutions I implemented, from UI improvements to architectural refactors, improved user experience, performance, and scalability of the application. While the project still has areas for improvement, the foundation we built supports future expansion. Most importantly, this internship helped me to develop both technical and soft skills, preparing me for a career in mobile development in future. Thank you all for your attention, and here is the reference list I used while developing this project.